Just stop this today. All right, so welcome to another bite time session. I don't know if you've joined before, but we do this every Wednesday where we pick a book or probably maybe a topic in cybersecurity and we discuss it usually about it over here on this platform. Yeah. So today we are going to be doing editorial from Hack the Box. By the way, if you don't know who I am, I'm Mark Sam. Yeah, and I'm the one supposed to host this session today. Right. So today we'll be working on editorial from Hack the Box. It's a pretty simple box with like with a very simple vulnerability, with very simple vulnerabilities, right? But some things in it could be a bit tricky, especially when it gets to foothold and everything. So we'll look at that today. So as usual, when you log into HTTP, okay, let me just give a brief description. Those who are not familiar with HTTP. So Hack the Box is a platform where you can find vulnerable machines to practice your hacking skills because if you are someone that is trying to hone your skills in the field of cybersecurity, you can't be testing your skills on live systems, right? Especially if you don't have experience, especially if you don't have live experience. Yeah, so a platform, we have things like Hack the Box, there's Try Hack Me, there's Ponto Dawn that you can test your hacking skills on. Can you guys see my screen?
Yes, please.
Okay, wonderful. All right, so over here, I've logged into Hack the Box and then I started this target, right? So I'm going to try to hack into this target. Now, most of the time, or mostly, the first thing that you do when you're trying to hack into some machine, right, is to do some enumeration. So we first start off with our port scanner, that is Nmap. Let me just maximize this. So say sudo Nmap. Is my text clear now?
Yes,
Response
it
is it
is from
okay?
my end.
Okay, wonderful. So we first start with our Nmap scan. We copy that target IP address, we paste it over here. Um, we say that we want to do a full port scan, and then we set the timeout to be 10,000. Right. So after doing the port scan, it would show us the various ports that are open on this box. So we can run the scan right now, but I've already run the scan on this box. So let's just take a look at the result. So I'm just going to cut editorial.nmap. I've already run the scan, and then we can take a look at the open ports that are on this box. All right, over here you can see that we have two open ports on this box. We have port 80 and then we have 22. Now, normally when you are going after a machine or you are trying to hack into something, you want to have things or you want to start with things that are more of like a low hanging fruit, things that are more likely to be vulnerable than others. Right. So we have SSH, we have HTTP. Normally we go for HTTP because HTTP normally would have an application that is running on it, like would that presents us with a larger attack surface. Right? But if you pick something like SSH, the attack surface for SSH is really small because if everything has been configured properly, it's very difficult to get code execution through SSH or abuse SSH in some sort of way. So we'll first go for HTTP. We'll see what's right there. So we can put our IP in the browser and try to access it. Now because HTTP, because it's the HTTP protocol, right, we can try to access it from the browser. So I'm just going to open a new tab. I'll paste my IP address over here. Right. So you can see over here that it's not able to load the page. It says um, it's trying to redirect to editorial.html. Now, with most of Hack the Box machines, you have to add this domain into your host file. Now, the reason why you have to do this is because certain assets that are loaded on the page be using this domain. And if your system can't resolve that particular domain, you can't load those assets. So it's intentionally implemented to force you to add this thing to your host file. Just assets can load, everything on the page can load successfully. So let's just go and then add it to our host file. So I'm going to do that with I'm going to do that with them. I'm going to open up my host file with them and then paste in my IP and then the domain name that we want to use. So the domain name was editorial. HTTP. Alright. If in case maybe I'm doing something during the presentation and you don't understand, you can just alert me so I explain. Alright, so I've added
Okay.
that to my host file. I'm going to reload the page and let's see what happens. Alright, so you can see that happening into my host file. We've been able to load the page successfully. You can see that we have an application that is running on port 80. Now this web application, you can look around, try to view the source code of the web application and see what you can find. Uh, there's one trick you can use. You can just do Control U to see the HTML source code of the page. Yes. Now I like to do this because sometimes there are certain elements that could be hidden. Right? So you wouldn't see them from the rendered output over here. They could have some hidden elements. So if you just do Control U, you get to see what actually makes up the front end code uh, for the HTML and CSS basically. So you can see we have upload, we have about, we have one that connects to the web or the web boot over here. Uh, Now, another very important thing is that when you are trying to hack into a web application, right, you need to know how the web application works. Right, you need to know the various features that web application has. So it's advisable that you play around with the web application, right, and try to see what it can attack on the web application. So at this particular point, right, you are trying to discover your attack surface, right? You're trying to uh, you're trying to discover things that are possible to attack or features that you think that could be abused, right? Okay. So we have all these links over here, and even I hover over these links, you can see that it's just editorial.tv, and then we have the pound sign. If you look at the left bottom, yeah, if you look at the left bottom, you can see editorial.html that the pound sign, which means that it's not really going to take us anywhere. If I do the rest to these links, you can see that the same thing happens for these links. You also have a subscribe to our newsletter box over here. You can enter an email address and hit subscribe. I've already done this. This doesn't work, but for the sake of this presentation, let's just do that. So what I like to do, right, is I'd like to go to the network tab. Let me just make sure this is top. So any request I send on this page, right, should appear in this network tab. So if you want to know if this particular feature works on the website, right, you can just open the network tab over here. We interact with it, click on subscribe and see whether anything or any request gets sent in the network tab. Right. So I'm just going to use this email, click on subscribe and let's see what happens. Click on subscribe. So you can see that there's nothing happening, which means that this particular feature of the website doesn't send any data to the backend, right? So it's not something that it's not something that poses a threat, or it's not something that we can exploit in our case. Also, if you view the source code for that particular part of the website, so I'm just going to do Control U again. And just use instead. Right, so you can see that it's a form over it says subscribe to the newsletter. But I said the form doesn't have any action or doesn't have any method, that it doesn't have something specific that it's supposed to do. Right? It's just a form. It's not really interacting with the back end. So it's not something that we can attack. Right? So that's just by the way. We can keep looking through the application. You can see they have some photos over here. What I like to do sometimes is I want to see where these photos are stored on the server. So I'll mostly open it in a new tab to see where it is being stored. Over here, you can see that it's being stored static images, static slash images. And just by seeing this, right, I can start to suspect that it was written in Python or some Python framework. Because normally when you're writing web applications in Python, right, this is how the directory structure looks like. This is how it looks like. I'm not saying that is always how it's going to look, right? But it's something that you can keep at the back of your head, right? Because in some cases, some developers may also choose that you are going to arrange their directory structure like this. But that was just by the way. Right? Let's see what Wapalizer is telling us, whether it's able to identify whatever is running on the page. Alright, so over here you can see that the web server over here is Nginx. It's running on Ubuntu, and then you can see that we have a Vex proxy over here. So over here, it's not really telling us what exactly is being used to create this website, but you can just play around with the website as usual. You can go to publish with that. Alright, so over here we have a form that we can actually interact with. I think if we view the source code for this particular form, so let me just inspect. You can see that we have an action over here. We have action is equal to slash upload, and then we have the method being post, which means that actually gets to interact with the server, which means that this is this is a possible way we can get maybe code execution on the machine, or maybe probably find a vulnerability on that particular server. Right. So over here, it's asking us to input certain information. There's cover URL, there's book file. So over here we can upload file, and then we can enter the book name and all these things. And after entering all these things, we can send the book info. Now, one very interesting tool for me over here is the cover URL. Now, anytime a website is asking for a URL, right, it's possible that there could be a vulnerability called SSRF. Now, SSRF is where you get the backend server to make a request on your behalf. You understand? So I'll explain it into details very soon, and then you get to understand how it works better. So right here we can interact with the form, right? So one thing I'm going to try to see if this website is vulnerable to SSRF, right, is that I'm going to spin up my own HTTP server, and then I click on preview. I think when you click on preview, right, it's going to try to fetch that particular image from whatever URL you have given it, right, and try to preview it over here. So I'm going to enter my attacker controlled web server, right, web server URL. I click on preview and see whether it makes a request to my server. Now, if it makes a request to my server and I look at the IP, and the IP belongs to that of editorial.html, then I know that we have SSRF on this particular website.
And then, it was under 19. Oh.
Hello? I think there's someone's microphone is on. Can you mute?
Yes, please.
Thank you. So let me just put this on the side. Let's put this on the side. I hope you guys can still see. So I'm going to start my Python web server. Okay, but before that, let me just check my IP address so that we know which IP address to enter the form. So it's 10.10.14.176. All right. Then start my Python web server. All right. So my Python web server has been started. I'm going to enter this link. I'm going to enter this link here, right? I click to and see whether I get any request from my server. So now my server is running on 48,000. I'm going to enter the port there. All right. Now that it's working, I can just click on. Now that I've entered everything, I can click on preview. All right. When I click on preview, right, you realize that we get a request from the web server that is hosting editorial.html. Right. So you can tell we have 10.10.11.20, which means that there's an SSRF on this website. Which means that SSRF is on this website. Now that we've been able to discover SSRF, how can we escalate this attack, or how can we leverage on this particular vulnerability to maybe gain or code execution on the machine? Right. There are so many ways of gaining RCE with SSRF, but before you can get RCE with SSRF, you need to understand the how the website was built properly. Like this request that is being sent, how is it being sent? Is it that it is running some OS command with curl and then making that request to a server, or is it that it's maybe using some inbuilt library in the language that was used to build that particular website? You understand? So what I'm going to do is that I'm going to spin up a Netcat server. a Netcard listener, right? And then I'll enter the URL over here. Now, what will happen is that would have access to
Yes,
like
yes,
the
yes. But there
entire
was no
HTTP
message.
request. So we would be able to see.
Very much.
Thank you very much. Yeah.
Bye.
Please, can you mute? All right. So where was I? Are you guys following?
Yes, please.
All right. So I was saying that like this particular request that is being sent to a server could be sent through different means. Right? It could be that the web application is running an OS command, maybe curl or some other tool that is making the request to our server. Now, to be able to understand how we can abuse this SSRF, right, we need to know how the website is sending this request or what the website is using to send this request, right? So I'm going to spin up a Netcat listener. Now, the reason why I'm using Netcat this time and not a Python HTTP server is that with Netcat, I get to see the request headers, right? I get to see all the request headers, and mostly in the user agent, right? Mostly in the user agent, the name of the name of uh, the name of the app or the name of the tool that is being used to send the request would be leaked most of the time. Like most of the time, the name of the tool that is being used to send the request will be leaked. Right. So I'm going to spin up my Netcat. So Netcat, I'm going to listen on 8989, and then I'm going to enter the URL over and then click preview. So I'm going to enter HTTP and 10.14.176, and then on port 8989, and then I click preview. Now after clicking preview, let's see what happens. Or let's see what is displayed in our Netcat. So over here you can see that we made a request to our Netcat listener, right? And then you can see that it's trying to get the resource from our server. But the most important thing over here is the user agent. Over here you can see that the what is being used to send the request is being leaked over here. Over here you can see that it's using Python request to send a particular request. Now, if you read a bit about Python requests, right, you can choose to. Okay, one thing you can do over here is that right now that you do is Python request that is being used to send this particular request. Right? So Python request is a library in Python, right? That you can use to send requests. So we can just do a search and see whether there are any vulnerabilities available for this particular Python request version. Okay, so I'm going to do a search and I'm just going to say exploit. All right, I've already tried this, right? And I didn't get anything substantial. Now the reason why I'm showing all this is because when you are trying to hack into a machine, right, you need to explore, you need to approach it from a perspective where you know nothing about it and you're trying to gather information, right? So over here, I'm not getting any exploits for Python, this particular Python request library, but at least I know that this particular website was possibly even written with Python, right? Because this request that was sent, you can see it over here, it's Python request library that was being sent a request. Now, if you, I think with SSRF, there are so many ways of getting RTE. You can do SSRF to RTE, but the thing is that for every for every uh, for every SSRF, right, it could be implemented differently, right? It could be implemented differently from the way your SSRF is implemented. So it could limit you. Certain attacks that you see that people will be able to gain RCE on target using SSRF may not work for you because of how your target was built, right? So from my research, I realized that you can't really use other protocol handlers. You can't really use other protocol handlers with the Python request library, right? So when I talk of protocol handlers, this is what I mean. Let me just show you that briefly. Now if I do HTTP, right, and then I do maybe google.com. Now when I think of protocol handlers, this is the protocol handler. So for example, in a case where you want to read files on the system, you could do file and then maybe etc .wb, right? And it could make a request using this protocol handler, you'll be able to read files on the system. But over here, because I know that it's Python request that is being used to it's being used to make the request. I read a little about it and I realized that you can't actually use any other protocol handlers with Python, right? We can just confirm that we're using ChatGPT. Let's just confirm that using ChatGPT. But you can also do a search, right? I want really quick answers. That's why I'm using it. So I'm just going to say which um, so I think you can use FTP and some other ones, but you can't really use the file protocol handler, right? When you are using Python request, which means that we can't say we probably can't get how should I even put it? We can't read files. We can't use the file handler to read files on the system, right? Okay, so for those who just joined, right, let me just go to what I've done briefly. So first of all, we did a scan on that machine. We found two ports open. That was port 82 and port 80. As an attacker, we always go for the one with the low hanging fruit. That's port 80. On port 80, we realized that there was a web application running. Browsing to the web application, we came across this form over here that we could interact with. Over here, you can see that the form takes in a URL, right? And then you are able to preview the contents of that URL. Now, from that alone, you can infer that that particular website could have an SSRF, right? So we tested this, put our own attacker controlled URL over here, and then clicked on preview. We realized that the request came in from the server, which means that there's an SSRF over here. Now, if you try very hard, right, and you still can't get, I'm continuing. If you try very hard and you still can't get RC with SSRF, right, what you can do is that you can try to access things that are running in the internal network of that particular machine, right? So maybe there's some other web server that is running inside the machine, right? There's some other website that is running, whether we can maybe access it. Maybe that particular website or that particular web server could be vulnerable, right? So what we are going to do is that we'll place a URL over here. We'll place an internal URL over here and see what happens. Now to make things clearer, I'm going to intercept the bit so that we see the response and it's much clearer. So let me just start that. Okay, so how about that is starting? Does anyone have any questions? Anything anyone wants me to elaborate on? Or any contributions? It looks like everyone is okay. No one wants to contribute or any questions. We will just proceed. Let's just wait for
I think I have a question. It's really not a question, but I just want to get something really like
Okay.
clear. Can you
Okay.
take me through the protocol handler again? How does it work exactly? It looks like work like remote file execution.
Okay. So when
Okay.
I said protocol handler, right? So if
Yeah,
you have a URL like this, right? This
yeah,
is the protocol handler. This file thing over here is the protocol handler. Now uh, the protocol handler would let the PC know which application to open with that or to use to open that particular URL, right? So if I enter, I'm trying to get an example. you realize
Okay.
that there are certain links that when you click on inside your browser, right, it will open an app. Like for
Yes.
example, if you click on a Zoom link, it will open an app. So what is happening is that the browser is able to detect the protocol handler, and then it knows the right app to use to open that particular protocol handler. There are other protocol handlers that can be used to read files, like this file protocol handler over here, like this. You can use to read files. So I can type in file just to test this, right? I can
Yes.
type in file http file wd. No, let me just do it. And you can see that I've been able to read the content of my host file, right?
Yes.
Because the browser understands this protocol handler and it knows how to handle URLs that look like this, right? So
Yes.
what I was saying was that over here it's Python request, the Python request library that is used to send the request. And with the Python request library, it doesn't accept this protocol handler. It doesn't accept this file protocol handler. It just accepts HTTP and HTTPS.
Okay.
And that was from the research I did, like the small reading I did. Maybe there are other protocol handlers it would accept, but over here wasn't accepting files, which means that you can't actually abuse that to read files, or you can't use you can't abuse that to read files on the system.
Thank you.
Have I answered your question?
Yes, please. Yes.
Okay. So Redshift has started. I'm going to intercept this request with Redshift. Okay, so let me just turn on proxy. I'm just going to enter something here. Just so I can intercept it then. And then I click on preview. Let's see. Okay, my intercept wasn't on. Okay. So let's use HTTP. Click on preview. Should be able to capture the request. Okay. So we have the request here. Let me just send it to the data. Then we can play around with it. Then I can now send this off. I can disable this now. Right. So what happens over here is that anytime we click on preview, right, it will send this URL to the backend, right? And this the backend will try to make a request to that particular URL. It will try to fetch the image if the that is if the web server has exposed any image, right? And then it will return a file that contains that last file. Like so, for example, let's just test this one. So I'm going to host I'm going to host a file. Let's just call this test. Okay, this is a test. And I'll type it to test.txt, right? Then I use my Python server to my Python web server to push the file. So let's just see how the website is going to behave towards this. So my IP is 176, 148,000. Name of the file is text.txt. When I click preview, see what happens. It will try to fetch the file from my web server and then it will try to preview it over here. So let me just go back to 3,000. Maybe I made a mistake in the IP. Am I intercepting? Let's just see let's click preview. I might have made a mistake in the IP. Then we should need to check the IP. 14, that's 176. Let me go back. Okay, so you can see over here, it's retrieved the file called test.txt from my web server, and then it tries to preview it over here. And let me just redo it. It will preview it. Then you can see over here, it's trying to preview it over here, but because it's not a valid image, right, it can't preview it properly. What we can do is we can open this in a new tab. So we can open image in a new tab, and okay, it is not found. Let's try it again. Let's try to open a new tab. So what it does is that it fetches the contents of this file, right? It fetches the contents of the file that is on my server. That is test.txt, right? And then it saves it into a new file with some random string, right? It changes the name to some random string and saves it to that file. So what happens is that it would return this file to the front end, and then the front end will try to retrieve this file from the back end. So basically trying to preview the image. Let me just do this. I don't know, sometimes it messes up. I don't know why. But another thing, if I open in a new tab, it should download that file. You understand? So over here you can see that the file got downloaded.
Yes.
So where you can say we have what this is a test. So it's retrieved the file that was on my system, right? Uploaded it to the web server. And then like it's uploaded to the web server. I saved it as a new name that this is a test. And then previewed it for me. Right. So any URL that I would enter over here, what it's going to do is that it's going to fetch the contents of that particular URL. Right? It would save it to a new file and give it a new name. Right? So what I can do is that I can try to access files that, or I can try to access maybe servers that are hosted on the same box, right? So internal servers that are inside the same box, right? So we all know that if you want to access an internal resource, right, you normally use 127.0.0.1 to access an internal resource, and then you specify the port. Now over here, we don't know what the port is, but that's another problem. We don't know what the port is, so we can't really, we don't know what the port is, so we would have to guess, right? So under a number of circumstances, maybe you put this here and then you send it to the intruder, right? And then you start brute forcing. You start from maybe the number, maybe 40 or something. Maybe it could be any number, or maybe it could be from the number one, right? And then you look at the responses and see whether any of them gives you anything valid. Now, what happens over here is that let me put my attacker control web server over here. Again, I want to show you something. So it's 10.10.10.14.176.8,000. Then it was test.txt. When I send this request, let's see what happens. Right, you can see that it says that we have the file, or the file has been saved to a static upload, and then with some random name over here. Now let's see what happens if this particular URL is wrong, right? Or nothing is over there, or nothing exists over there. Let's see what a web server would do over here. You can see that over here right now it's returning a JPEG file. Now the JPEG file is what you see over here, like on the original web page. Let me reload it. This is the JPEG file is returning. If I open it in a new tab, right, you can see that this is the JPEG file that is viewed over here. So if that particular resource exists, right, it will return. If that particular resource exists, right, it will rename the file and it will be inside the uploads directory. If it doesn't exist, it will just return this as /photo URL, that default image that is already on the website. Right. So using this information alone, we can use that to brute force. So when we brute force and we check the responses, right, we check the one that gives us a valid URL, like the upload slash that random character, right? So I can do 127.0.0.1. Then I'm just going to put a random port number over here. but I will change it later on. Then I'll send this particular request to the intruder. Now, I'm only doing this for demonstration, like under normal circumstances, like I wouldn't do this because I don't like to bombard the server with too many requests. But this is just a demonstration for easy understanding. And sometimes if maybe certain ways of doing things don't work, then maybe you can try brute force and attack. So over here, I'm going to change this port number to I'm going to change this port number for every single request. I'm going to start from the number 1000 because normally the most common port are like 1000 and above. We can also do maybe port 80 and the rest. The best thing to do, right, is to get a list of commonly used port numbers, right, and then use that for your attack. But I don't I don't really want to waste too much time over here, so I'm just going to start from 1000 to like maybe let me see 1000 to like 8000, and let's see which ports that we can find, or let's see the responses that we can find. So this one is going to be numbers, and then it's going to range from 1000 step is 1000 to I said 8000, right? Okay, and then we start the attack. So you can see our request going in. We can see our status codes. We can see the responses and then the length of the responses over time. Right, so keep going, Now this is because this is a free version of the this slow. So where you can see we still have this splash photo over here, which means that that particular resource doesn't exist. So as it keeps going, we can keep looking at the responses. We can keep looking at the responses. Now this is really slow. Like I think this is because the free version. It's because it's the version of that. There are faster ways to do this. You can use Stable Intruder to do this and make it faster. But for the sake of time, I already know the port. I already have the port in mind. For the sake of time, I'm just going to reduce the payloads, right? The number of payloads that you're going to use, so that you can see it. So we don't spend too much time on these things. I'm going to describe this attack. I'm going to start from port. Let me see. 488825550. Let's start that. So I've reduced the range, right? So that doesn't take too much time for us to get to the port of our choice, or the port that is going to review something interesting to us. Yeah, is there any question you want to ask? Is there something you want to ask? I think I heard someone speaking. Oh, this is too slow. The free version of that is too slow. Let's just be patient. The port is actually port 5000, right? The port is actually port 5000. I just wanted to see what it would look like if you have no knowledge about it and you are trying to enumerate to find something substantial. So you can see that for each of them, when I check the response, it's still returning this splash photo and splash photo, right? Let's see what happens when it gets to 5000. Let's see the response when it gets to 5000. But as we wait, are there any questions that you would like to ask? Maybe something that I didn't explain clearly. Now, another way of being able to recognize the port that is running, right, or the local port is by guessing, right? Over here, you guys that it was kind of that there. So you can assuming and saying that, oh, maybe there are other Python servers or there are other Python web servers that are running internally in the network. So you can look at you can start thinking of some Python framework that could be used to create web applications or web servers. Yeah, you can think of Flask, you can think of Django. So when you think of Flask, for instance, when you take Flask, for instance, normally when you run Flask, a Flask web application, it has a default port on which it runs. So we can just do a quick search and say, what is the default port? Default port for Flask apps. You can see that the default port of Flask app is 5,000. So before you even start a big port, you can do this few check. If they don't work for you, then maybe you can move and then you can try the big port. Over here, we have 5,000 over here. So we could actually try with this and see whether it works. And then, so if you have like very little knowledge about the application, right, you could also try other Python frameworks to see their default port, and then you just keep trying to see whether you get anyone that is exposed internally. Let's see whether we are still not there yet. But it says 5,000, right? Let's go to our repeater. It says Flask runs on 5,000. Let me check other. Let's see, what does Django? Which port does Django also run on? Django runs on 8,000. The default port for Django is 8,000. So I'm going to try both 8,000 and 5,000. Let's see what the responses would be. So when I try 8,000, we are still getting this splash photo, which means that that particular resource doesn't exist on the web server. Let's try 5,000 and see. Okay, so you can see that with 5,000, we actually got this static upload slash this UUID over here. So I can copy this, right, and try to access it. So I'm just going to replace this with the URL just copy and then hit enter. Okay. Like it says resource not found. Let's try it again. And
double. The status is double. The typing at the top. Status.
oh, okay,
SS.
okay, thank you. So let's try this. Okay, still not found. Now there's a cleanup script on the box, right? There's a cleanup script on the box. So after you have uploaded the thing, it's not saved on the box temporarily. It's just going to be saved for some time. So right here you can see that we actually get something in the file. So we are actually able to access the web root of an internally running server, right? A server that is running internally. We're able to access the web root of that particular server. Now let's go back to our bed. Let's see whether the intruder is able to find that particular port. Just in case maybe we had very little knowledge about the application and we want to do some reporting to be able to detect that there's an application inside the machine running on 5,000. It's an internal web server running on 5,000. Okay, so for this thing is taking so long. Well, I'm going to copy those sets. Now because when I'm using the browser, I have to consistently keep downloading it. I'll use tail over here so that you don't have to download it every time. So I'm going to kill this and let's see what happens. Okay, so you see that it's in 404. Previously, we access the same URL and be able to download the file, but when I say 404, because there's a cleanup script that after accessing this URL, it just deletes it. So let's try to do, which is send, copy this URL, and come back. And then paste this here. Okay, so you can see that we have the data right now. It's looking ugly. I'm going to use a tool called JQ, right, to make it look nicer. Okay, so it's looking nicer over here, right? And what it looks like over here is that it's returning something like a documentation. It's returning something like documentation. I don't know whether it's for other developers to loop on and be able to build stuff on top of this API. But then you can see it's returning some documentation over here. There's a route, there's an endpoint called API latest metadata messages / promos. There are other interesting endpoints over here. So now that you know that there's server that is running internally, you can actually take these endpoints, right? And then you use them over here and see what those particular endpoints return when you make a request to them. So I can make a request to this. We get the URL, copy. We can clear this. Paste the URL there to the tail, and it is not found. It is not found. So we can keep trying the rest of the URL. Now, if I'm going to try every single one of them, it's going to take a very long time. The most interesting one over here to us is API latest messages / authors. So these are basically, it looks like these are messages that were left there by authors or developers. It is retrieve welcome message sent. I think there's a mistake over here. There's a grammatical error. Sent to our new authors, right? So it looks like they are sending some new messages to new authors. They're sending some messages to new authors now. If that could contain use information, so let's just make that request. And then you grab the URL, curl it, and see what we get. Okay, now before we do this, let's go back to the intruder and see whether it fits 5,000 and whether it works. Okay, so you can see that over here the response. You can see the response over here, and you can see how it's different from this other response here. So if I go to 5,000, see the response here, and then if I go here, see the response here. So that is what you can use to detect there's a port on this box, right? Or there's an internal service running on 5,000 in this box internal. In this box is internal. So let me just close this now. Any questions? Any questions anyone wants to ask? If you have any questions,
No, sir.
Yeah. Any questions? Or we should move on. All right, so I'm making a request, an internal request to this particular endpoint, and that is trying to get messages of the author. I'll copy the URL. Let's paste it in our terminal. We use curl to retrieve that particular resource and see what's there. Oh, this looks interesting. Let me type it to JQ. Beautify. Okay, it's welcome to the team. We are thrilled to have you on board. We can't wait to see the incredible content you bring to the table. Your login credentials for internal forums and authors sites are username dev and password dev API with an exclamation mark and an @ sign. So we have the password over here, we have the username inside here. And remember when we were doing enumeration at the beginning of the box, we found SSH open. So we can try to see if we can use these credentials to SSH into the box. So we are going to do SSH, and then the username we found was dev at editorial.htb. Then we hit enter. We enter the password and see whether we can get access to the box. And we have access to the box. So some information was leaked over here, right? Probably the person who leaked this information was that after all, anyone that is inside the box or inside the network of that particular machine is a legitimate user, right? But over here, SSRS give us the opportunity to access resources that exist internal to the machine, like like in the machine's internal network, right? So that is the flaw over here. Be able to attain the password of that particular application, and we have SSH into it. So right now we are currently dev at editorial.htb. Any questions up to now? Any questions up to now? Is there anything you want me to clarify?
No, everything is okay.
Wonderful. I hope everyone is following.
Yes, please.
Okay. So when we hit ID, we can see that we are there. We can try to check. So right now we are in the box as dev, right? We can see we have to see if we can escalate our privileges to the root user. So anytime you enter or you get into a machine, normally it's very difficult to get into a machine as like privileged user, right? So normally when you get into a machine, you will be a low privileged user. As an attacker, you need to abuse certain things that are on the machine to be able to escalate your privileges. In certain cases, it may work. In some other cases, it may not work. But that now, because this particular box is designed to be vulnerable, it is designed in such a way that we should be able to attain what privilege escalation on this box. So we are going to look around the box, check certain things, and see what we can use to escalate our privileges on the box. Now, if we do sudo that L, right, it's supposed to preview maybe our pseudo privileges on the box, like things that we can run on the box as maybe a root user or as some other user. Basically, the pseudo privileges we have on the box, right? And then I enter the password for dev, and it says, sorry, dev may not sudo on editorial. So dev doesn't even have the permissions to run sudo on the editorial box, right? So we can start looking around the file system. If that is not possible, we can look at around the file system, try to find anything that is used here in the file system. Right? So over here, if you are someone that's interested in Flask, we have the user.txt where you can read the contents of the file, and then you can submit your flag. We have bash history over here, but unfortunately it's being typed to dev now. Normally, if it wasn't public typed to dev now, you can just read the contents of it. Maybe someone could have leaked some password in the bash history file. There are a lot of ways to go about privilege escalation. Over here, I'm going to look around. So I'm going to visit the first directory, that's the apps directory, and see what is over there. When I do ls, you can see that there's nothing in it. But the trick is that the particular file that we are looking for is actually a hidden file, right? So you can see that there's a .git file. Now, and then it's any file that starts with a dot, right? It's a hidden file. And if you just do a normal ls, you may not find that file unless you do a ls minus a before you can see that file. All right, so we have a git file over here, and if you guys know or you guys have used Git or you guys know about Git, Git is a version control tool, right? It's used to it helps developers to control the version of the application they write. So what Git does is that it tracks changes to you make to your code. Yeah. So when you see a .git directory on like when you see a .git directory on a server or an exposed .git file, you can try to interact with it and you can try to do some enumeration and then see whether it's able to leak anything, any history, right? Any file it has tracked, it can leak it to you. So what we can do is that we can type log, right? And it's going to show us a log of all the commits that have been made by the developers. Over here, you can see that we have quite some number of commits over here that was made by the developers. And then you can see that we have some commit messages over here. So this one says bug fixing API port endpoints. Okay, and then so what I'm going to look for over here is an interesting comment that may want me to that may convince me to look at some particular to look into that particular comment. Right? Now, anytime you what's the name? Anytime you commit with Git, right, it's going to save the current. It's going to keep like the current snapshot of the way your code looks, right? And it's going to give it these commit numbers, right? Try recorded numbers. Let's just see a commit string. Now this commit string is used to identify each version of your code. So have to keep updating it, right, and making commits like you get different versions of that particular code. So we have this particular version, and when the person made this particular commit, the the message the person wrote. It says what downgrading production towards development. When you see prod and you see dev, it means this means prod. This means production. This means development. Right? It says create API to editorial info. Like there are a lot of commits over here. So we are going to look at ones that are very interesting. And the one that is interesting to me is this one. So I'm going to look at this particular commit and see what the code look like at that particular point in time. Now there are automated tools that can do this. There's a tool called GitLead that you can use to do this. But normally I don't like drop stuff onto the box. So I don't like to drop stuff onto the box. So I just try to do it manually. So as I said, that was an interesting that particular commit was pretty interesting to me. If you look at the commit, you realize that this was what the code looked like previously, right? And then a change was made to the code, and Git actually keeping track of these changes, right? So you can see that previously the person puts production environment credentials over here. You understand? So over here you can see that instead of the username being dev, right, it's prod over here, and then the password is also the production password over here. So you can copy this production password. If you catch the contents of etc password, right? etc password you can use to list, you can use to find out the users that are present on the box, right? And then I'm just going to grep. I'm just going to do sh so that the output is not too much. So you can see that we have this. You can either have user prod and we have user dev. Right? So right now we have the password for user prod. We can use the su utility to change user to that particular user, and then we are in the box as prod now. So you can see we are currently prod. So we have used this exposed Git directory, right? We are able to see what the code looked like before it was changed, right? So previously it looks like the person was running on the production environment, right? And then the person later on changed to the development environment. So when the person see the change, the person changed the password, but because it tracks these changes, all these changes, you can still see the history, right? So let's continue. So now that we are into the machine as the dev, sorry, as the prod user, right? Let's just check our sudo privileges. I'm going to enter my password, and then you realize that this particular user prod can run, it can run this clone prod change. This particular Python script clone prod change on the box as was the root user. And then when you run clone prod change, you can enter anything as the argument to that particular script over here. Now, when you see a wildcard, it means that it basically represents some arbitrary length of data, arbitrary amount of data, right? And you can see this is a Python script over here. Let's see if we have read access to that Python script. We can do an ls minus le, and then you can see that here we have read access to this particular file because we are in the production group. So you can see over here the users in the production group have read access to the file. So let's just read the file and see what it contains. Let's see if there's anything in the file that we can use to escalate our privilege. All right, so over here we have a Python over here. You can see that we are importing OS, importing state, importing Git from repo. From Git, they are importing repo, right? So basically, what is happening over here is that they are using a Git library in Python to clone repositories, right? So whenever this script is being run, right, and then you pass it the name of the repository that you want to clone, right, and it's going to clone that repository for you. So I think what this script is being used to do is that it's used to clone like changes, right? It's used to clone changes that are made to the production environment. When when it clones those particular changes, and then it saves it into this particular directory. That's opt internal apps and then clone changes. All right, so we have this Python script over here. We have to see how we can abuse this particular Python script. Over here, you can see that they are using a library called the Git library, and that is what is mainly used to using the URL over here. So one thing you can do is that you can go on the internet and then you can do a search about this particular Git Python library and see whether it's vulnerable to any attack. Right. So you can come to your browser and let's say Git Python exploits. And the first thing one of the first things that you see over here is a remote code execution in Git Python. Now over here, I'm skipping a lot of things. What I'm supposed to do is that I'm supposed to check the version of Git that is even. I'm supposed to check the version of this Git library that is even running on this box, right? And then do a search to see if they have vulnerabilities associated with that. Because it could be that this Git over here is the current version, or this particular Git over here is a version that doesn't contain those vulnerabilities, right? But I'm just doing a random search. I try it and see what it works. So over here, you can see that there's actually a remote code execution vulnerability on this Git library that you have over here. What happens is that if you enter this particular command while using the library, right, you can obtain remote code execution, or you can obtain code execution. So what I'm going to do is I'm going to copy this table, right, and then I'm going to paste it. I'm going to pass it as an argument to the script. Now you realize that we have URL to clone over here, and this is obtained from command line arguments, right? So this particular asterisk represents the other command line arguments that you can pass to the script. And then when you pass in those command line arguments, they are assigned to URL to clone. And then over here, you can see that we have clone form, and then that particular URL to clone is replaced with what URL to clone, right? So what happens is that whatever argument you pass over here just ends up being here, and then the code is being run. And if you look at the vulnerability over here, you can see that the malicious code was placed over here, right here. Yes. So we can just copy this, right, and pass it as an argument to the script and see what will happen. Whether this pawned file will get created in the same directory. Right. Okay, over here, Carl, I might even tweak it a little that it appears in the current directory. So I'm going to copy this script, run it with sudo, right? Because we have permission to do that. And then we have the command line argument, which I'm going to put in double quotes because there are spaces between it. Let me just move this to the top. Okay, perfect. Oh, that's UI. Then I'll be facing a payload. Payload, yes. So So instead of it creating it in the same direction, I'm going to create it in my current directory. I'm going to dot forward slash and need to be found. Right, so now after running this particular script, it's supposed to, if this particular RCE works, right, it's supposed to create a file called found in my current directory. And that particular file is supposed to be owned by the root user because we are running this particular script in the context of the root user. Let's just run this and see. Okay. There's a small mistake I made. I didn't bring Python over to the Python 3. Let me just copy this thing. Let me just copy the exact same thing. The way pseudo privileges are given, if you don't use the exact same command that comes with your pseudo privilege, right, it wouldn't work. So, and then let's see what happens. So let's see there's a file called pound on the system. Okay. So it's not there. Let's try it to do. Okay. Still haven't been created. Okay, let me create in the same direction maybe for some reason. Not working here. Okay, now let's view what the same directory. And then you can see that we have pound over here. You can see the file that's we created has been created over here. and then it's being owned by the root user, right? It means that we have code execution on the box. We basically have code execution on the box as the root user. So whatever command we enter over here, right, will get run on the box as the root user. So one thing we can do is we can place an SUID, or you can make build bash an SUID bit. So anytime you run build bash, it will get run as the root user. So I'm just going to do change mode, right? 4777. Now this command is just to make build bash an SUID. And then I can run this. Now before I run this, right, I just want to show you the current state of bin bash. That when I run it, you know that there has actually been a change. Okay, so you can see right here, there's no SUID bit set on bin bash. And when I run this, let's see what happens to bin bash. Okay, right now you can start. An SUID has been set on bin bash. So if I run bin bash p, right, it will put me in another shell that is running as the root user. If I do ID now, you can see that effective user ID is the root user. And then we can cd into the root directory. So on this pause, and then we can see that we have currently the root user. Now, if you want to make things fancy, you can fill the private keys in the execute directory and probably SSH into the box later on. That is that in okay, there are only authorized keys here. Okay, but one interesting thing you can do is you can create your own private key. Right? You can do SSH agent. And then we can create our own private key. And then even we let to the video. Some reason it didn't get it. It is the first we have been doing. Okay. Okay, the statement as the fraud user. That's okay. There's probably a way to go around this, but I mean we are still in the box as the root user. We can try to get a real proper like shell instead of this bash thing over here. We can try other ways to get it, but we are currently running as the root user. I mean we can even cut Etsy shadow. So we are the root user. Yeah. So that's basically it for editorial from HTTP. Make it simple. If there are any questions you can ask. Hello.
Hello.
That is for editorial. Editorial from HTTP. We have access to the box as the root user. Let me know what are your thoughts about the box. Maybe there are any questions, any contributions that you want to give about this box. Or is there anything I did that maybe was a bit confusing? You can just let me know. Okay, let me just read the chat.
I found it very interesting. I came in a little late, so I didn't know where it started from, but
Okay.
very impressive
Okay.
stuff.
Okay. So for the sake of those who arrived late, I'm just going to talk about what we exploited in this box to gain code execution. Right. So first of all, when we did our nmap scan on the box, right, we realized that there was port 22 and port 80 open, and as an attacker, we go for the ports with low hanging fruit, the ports that you can easily attack and maybe easily get vulnerabilities. Normally, when you go with SSH, very rare where you can actually gain RCE through SSH. So you can actually exploit SSH in some way if you don't have valid credentials. Right? So we went with port 80, and then when we accessed port 80 from our browser, we realized that port 80 was running an application that was built with Flask. Later on, came to know that the application was built with Flask. But then browsing through the application, we saw there was this particular form. And inside that particular form, it gave us the opportunity to enter a URL that will fetch an image that's going to be used for a book. Like it, okay, so the whole website, like, it's supposed to be a website that helps you publish a book. Like, so you're supposed to enter a link that will lead to an image that you're going to use for your cover, like your cover page on your book, right? And as attackers, we chose to enter a malicious URL, right? First of all, we wanted to identify something called SSRF. SSRF, the full meaning of SSRF is server-side request forgery. That's the full meaning of SSRF, server-side request forgery. Now, what happens with SSRF is that we're able to get the box, right? Or we're able to get our target to request on our behalf. So whoever is on the receiving end will think that the request came from the server, right? But it actually came from us, right? So with SSRF, we can perform like a whole variety of attacks. We tried to escalate SSRF to RC, but that wasn't really working. So what we did was that we tried to access resources that were running internally, right? So we tried to see if there are any HTTP servers that are running internally. We changed the port number. So basically, we are trying different port numbers to see which services were running locally in the box, right? And then we came across one service running on 5,000. After accessing that service, we realized that when you access the web routes, right, there are a lot of endpoints that you can access on that particular server. And when you access the web route, it gives something like a documentation of the endpoints that you can access. There was one interesting endpoint that when we access, right, it gave us credentials. And the main logic behind it was that the person whoever put those credentials over the thought that so this particular application is internal to only that particular machine, right? Those who are external or the people that are external, right, cannot have access to that particular data. It's only those that are inside the internal network, and we trust everyone inside the internal network, right? But over here, our SSRF vulnerability gave us the ability to access services that were running inside the local network, and through that we're able to get the credentials. After getting the credentials, we use SSH to SSH into the box. We got into the box as dev, right? And then while we're looking at the directories, so when we got into the box as dev, we looked around the file system, we came across a file called the .git file. And .git is used to track changes that are made to code. So we just use the Git utility to interact with the .git directory, and then we realized that at some point in time, the production environment was changed to the dev environment. And when you look at the change, you realize that initially it was a production password that was set before it was changed to the dev password. So you copy the production password and we change production. We change the production user. After changing the production user, right, we viewed our pseudo privileges on the box and we realized that we could run a Python script at the prod user, right? And then looking at the Python script that we could run, we had read permissions to it, so we read the code and realized that it was using the library called Git. We did a small Google search and realized that Python Git has an RCE, like a remote code execution vulnerability, where we can abuse it to run arbitrary code, right? And the entire command was being run as the root user. So it means if you can abuse something that is inside that script, you can get the opportunity to run as a root user, right? So we copy that exploit, we use that over here inside the box, and we're able to run code or execute as the root user, and then we finally became root over here. So that was a summary of the box, the entire box. I hope everyone is satisfied. I'd like to hear from you guys. I don't know, no one is speaking over here.
Oh, that's very impressive. Very
Yeah, I
impressive.
joined the class, that's why.
Okay. I think some of you are from Gameplay. We have some Gameplay guys here.
Yeah.
Oh, that's wonderful. That's wonderful. But, I hope you enjoy the book. We do this every Wednesday. I don't know if you are in our discussion or with every Wednesday, and you don't always have to just come and watch, right? You can contact us if you want to have anything to present, right? And then we'll give you a time to come and present. It could be that maybe you want to speak about some particular for cybersecurity. It doesn't always have to be maybe a vulnerable box that you are going to form or something. If you want to talk about a particular concept in cybersecurity, maybe you want to talk about how to get career in cybersecurity, you want to talk about how to get started in cybersecurity, you can come and talk about that over here in the group. Over here on the meet, right? We are trying to make the Bytime session community more lively, right? So we sent out this form where you have to fill and then maybe suggest activities that we could do in the channel to make it more interesting. You understand? And Bytime sessions were set up for us to be able to share ideas, right? And then we learn from each other, right, in the field. And anyone that wants to start anything in cybersecurity can just join Bytime sessions and learn from people that are already in the group. We learn from ourselves and then we grow together. Right. So if you want to do any presentation, right, you can just see any of the moderators, right? You can just text any of the moderators and then we would find a time for you to come also present over here.
Can you please share the links, like the link to the WhatsApp group and also your contact details? I really appreciate that.
Okay, sure. I'll just drop that in the chat. Then just stop recording.
Okay, yeah.
Right.
Okay, I have something small to add.
Okay, yeah.
Okay, Maxam, you have done an impressive job.